Hello and welcome. In this video I want to show you some more examples related to chain rule. We want to find the derivative of the function y equals x plus 1 over x to the fifth. In this example, x plus 1 over x is the inside function and to the fifth is the outside function. To get rid of quotient rule when I want to find the derivative of the inside function, because note that here we have 1 over x. To find the derivative of this term, we have to use quotient rule. To get rid of quotient rule, I prefer to rewrite this function in the form of x plus x to the negative 1 to the fifth. In this new form, x plus x to the negative 1 is the inside function and to the fifth is the outside function. So the derivative of this function equals 5. We bring the power down to the front of the term as a coefficient and we reduce power by 1. 5 times x plus x to the negative 1 to the fourth. We leave the inside function alone. Times the derivative of the inside function. Derivative of x is 1 and to find the derivative of x to the negative 1 we have to use power rule. We bring power to the front of the term as a coefficient and we reduce power by 1. So derivative of the inside function is 1 plus negative 1. We bring the power down to the front of the term as a coefficient and we reduce power by 1. Negative 1 minus 1 equals negative 2. And this is the derivative of the function. And if you want, you can rewrite your answer in the fractional form. 5 times x plus, instead of x to the negative 1, you can rewrite 1 over x to the fourth times 1 plus negative 1 over x squared. Instead of x to the negative 2, you can bring x to the denominator and change the sign of the power. Another example, y equals a square root of x over x plus 1. A square root is the outside function and x over x plus 1 is the inside function. But I rewrite this function in the power form. X over x plus 1 to the 1 half. X over x plus 1 is the inside and to the 1 half is the outside function. And so derivative of the outside function equals 1 half, leave the inside alone, to the negative 1 half. We bring down the power to the front of the term as a coefficient and we reduce power by 1. 1 half minus 1 equals negative 1 half. Note that dy over dx is just another notation for derivative of the function y. Instead of dy over dx, you can write y prime. I am intentionally showing you different notations for derivative of the function to make you more familiar with these notations. Anyway, now we have to multiply this by the derivative of the inside function. Inside function is x over x plus 1. To find the derivative of this function, this expression, we have to use quotient rule. If you recall, derivative of f over g, derivative of a quotient of two functions, equals g bottom function times derivative of top function minus top derivative of bottom function over bottom squared. And so derivative of x over x plus 1 equals this expression. Bottom function, x plus 1 is the bottom function, times derivative of top function. In top we have x. Derivative of x is just 1. So bottom times derivative of top minus top. The top function is x. Derivative of bottom function. Derivative of x plus 1 is 1. Derivative of x is 1. Derivative of 1 is 0. So derivative of the bottom function is 1. Over bottom squared. X plus 1 squared. And this is the derivative of this function. If you want, you can clean up and simplify numerator of this fraction. X plus 1 times 1 equals x plus 1 minus x times 1 is just x. So in numerator we have x plus 1 minus x. If we cancel x from numerator, just remains 1 in numerator. And so dy over dx equals 1 half x over x plus 1 to the negative 1 half times 1 over x plus 1 squared. Another example. y equals square root of x plus square root of x. In this example, inside function is x plus square root of x and the outside function is this big square root. First, I write this function in the form of x plus square root of x to the 1/2. In this new form, outside function is to the 1/2 and the inside function is x plus square root of x. To find derivative of the outside function, we use power rule. And so we have dy over dx, or derivative of this function, equals 1/2 inside to the negative 1/2. We bring the power down to the front of the term as a coefficient and we reduce power by 1. 1/2 minus 1 equals negative 1/2. Times derivative of the inside function. Derivative of x is 1 and derivative of square root of x equals 1/2 x to the negative 1/2. Remember that a square root of x can be written as x to the 1/2. And with the power rule, derivative of this expression equals 1/2 x to the negative 1/2. So derivative of inside function equals 1 plus 1/2 x to the negative 1/2. And this is the derivative of this function. But if you want, or if you prefer, you can rewrite this answer in the radical form again. Let me remind you that any expression to the negative 1/2 can be rewritten in this form, 1 over a square root of that expression. So we can rewrite x plus a square root of x to the negative 1/2 in this form, 1 over a square root of x plus a square root of x. And we can rewrite x to the negative 1/2 as 1 over a square root of x. Another example. We are asked to find derivative of the function y equals x minus 1 over x plus 1 squared. To find derivative of this function, we have to use quotient rule. Let me remind you quotient rule. F over g prime, derivative of quotient of two functions f and g, equals g, the bottom function, g is the bottom function times derivative of top function minus top derivative of bottom function over bottom squared. And so derivative of this function equals bottom function. So we have to write x plus 1 squared times derivative of top function. What is the derivative of x minus 1? Derivative of x is 1, derivative of 1 is 0, so derivative of top is just 1. So bottom times derivative of top is 1, minus top function, the top function is x minus 1, times derivative of bottom function. To find derivative of bottom function, we have to use chain rule, because note that we have an outside function and an inside function. So we have to use chain rule. And derivative of the bottom function equals 2 times x plus 1 times 1. First, we take derivative of the outside function. We bring the power down to the front of the term as a coefficient and we reduce power by 1. And it becomes 2 times x plus 1 times derivative of inside function. Derivative of x plus 1 equals 1. In this case, because derivative of the inside function is just 1, it is negligible. Bottom squared. In bottom we have x plus 1 squared. We have to square it again. So bottom becomes x plus 1 squared. And this is the derivative of the function. If you want, or if you have to, you can simplify this answer. Note that we can factor x plus 1 in the numerator, because in the first term and in the second term we have x plus 1 as a common factor. If we factor x plus 1 from the first term, we have x plus 1. Note that x plus 1 times x plus 1 is x plus 1 squared. And from the second term, we have minus 2 times x minus 1. Now if we cancel x plus 1 to the 1 with x plus 1 to the fourth, y prime equals x plus 1 minus 2x plus 2 in numerator and x plus 1 to the third in denominator. And finally, x minus 2x is negative x, 1 plus 2 is 3, and we have minus x plus 3 in numerator over x plus 1 to the third in denominator.